Welcome to hydrology class. Today we will learn about meteorology and climatology. Meteorology and climatology are both branches of atmospheric science. They both involve the study of atmospheric processes such as air temperature, air pressure, and atmosphere. This is the comparison chart between climatology and meteorology. Climatology and meteorology. Welcome to hydrology class. Today we will learn about meteorology and climatology. Meteorology and climatology are both branches of atmospheric science. They both involve the study of atmospheric processes such as air temperature, air pressure, and atmospheric composition. Meteorology is the study of weather or all atmospheric processes including temperature, air pressure, and chemical composition, while climatology is the study of the behavior of the atmosphere and changes in temperature, pressure, and other atmospheric factors over a period of time. What is the difference between climatology and meteorology? This is the comparison chart between climatology and meteorology. From the characteristics of change, climatology related to long term. So the time period is between years to centuries or more, while meteorology is more short term, in time period of hours to days. In the characteristic of interdisciplinary status, climatology involves knowledge from atmospheric science, geology, and astronomy, while meteorology primarily only atmospheric science. So, in interdisciplinary status, the climatology is wider than the meteorology. From the characteristic of temporal orientation, climatology usually focuses on the past. So, the accident or incident which is already happened, while the meteorology focuses on the present and near future. So, for forecasting and for anything related to the present and near future, usually is related to meteorology. You can read more about this in the link below. When we talk about climatology and meteorology, we have to talk about climate change, right? What is climate change? Some of you already know, but maybe only some of you really know about this. So, the climate change is a large-scale, long-term shift in the Earth's weather patterns or average temperature. This climate system have varied naturally over the years. Change occur in cycles over tens of thousands of years, resulting in the Ice Age and interglacial warming periods. These cycles are connected to the shape of the Earth's orbit and the tilt and direction of the Earth's axis. Furthermore, the solar variability and volcanic activity have also impacted historic climate trends. However, this scientific research proves that natural causes do not account for recent climate change. 10 of the hottest years of record have all occurred in the last 18 years. Extreme weather events, storm surges, floods, heavy precipitation, tropical storms, heat waves, wildfires, and droughts have increased fourfold over the past 35 years, from 38 events in 1980 to 174 events in 2014. I bet this one is only in the US, leading to the cost of this disaster increasing tenfold. This is the sign of climate change. Yeah. The first one is the changing rain and snow patterns. There's also changes in animal migration and life cycles. There are less snow and ice in the mountainous area. There are more droughts and wildfires, higher temperature and more heat waves, stronger storms, damaged corals in the sea, rising of sea level, warmer oceans, and changes in plant life cycles. Because we live in the tropical country, yeah, we don't see any snow or ice, right? but we can feel the climate change in changing rainfall patterns, for example. Actually, the usual rain season is in the month with the end of birth. So September, November, October, December, it has to be rain season. But look at us now. Here we in the March, we still have rain. So yeah, that's because of the climate change. We have a changing rainfall patterns. Actually, we should be in the summer, but now we're still in the rain season. So, meteorology. Meteorology is the study of conditions related to weather and climate. There are a lot of meteorological data, but in this lesson, we will only talk about this here. Um, Air and soil temperature, humidity, wind velocity, air pressure, solar radiation, evaporation, and precipitation. Usually, the meteorological data measurements are made at meteorological stations. Here in Indonesia, we have BMKG. If you already know about that, this one is the map of the temperature. In our country, you can see there are Sumatra, Kalimantan, Sulawesi, Jawa, and Papua Island here. And you can see the different color means the different temperature. Like the colder the temperature and the lower the temperature, the color is different than the higher one. Okay. So regarding air temperature, the variables are varied. Usually it's related to rain, evaporation, and transpiration. This air temperature can be measured in a Stephenson screen, or in Indonesia we call it sangkar meteorology. As you can see in the picture, usually you can see the Stephenson screen in the airport. Usually it is located in a very open wide area, yeah, usually in the airport. It measures the daily average temperature expressed in Celsius and Fahrenheit. If you want to measure the maximum temperature or minimum temperature, a special thermometer is used. So you can see here the equation for calculating the average temperature. If you measure it in one day, like in 24 hours, you can use this life equation. Or if you measure the maximum or only the minimum of the temperature, you can use the right equation. A Stephenson screen or instrument shelter. This shelter is meteorological instruments. It includes thermometers, hygrometers, psychometers, and cell, barometer, and a thermograph. It is against precipitation and direct heat radiation from outside sources. So the meteorological instruments can be safe inside while still allowing air to circulate freely around them, because it has like a little bit of hole, so the air can circulate freely around them. And move on to the soil temperature. Here we have like a soil thermometer in the picture, ground or soil thermometer. And for the soil temperature, usually the recording is done in 3 times per day, in the morning, in the midday, and in the afternoon. And the depth of the measurement, usually 1, 3, 5, and 10 centimeters. And the data actually sometimes it has daily or monthly average. It also can be daily or monthly maximum or minimum. So it depends on the necessity. Next one is humidity. So the air absorbs the water, and that's why the humidity really depends on the temperature. Usually the one a place with higher temperature have lower humidity than place with lower temperature. And this relative humidity can be calculated with this actual vapor pressure and saturated vapor pressure. So it becomes like a percentage of humidity. And the unit is also depends, usually is bar or millimeter mercury, millimeter Hg. And 1 bar equal to 10 power 5 Newton per meter square. Yeah. And you can calculate the the saturated vapor pressure with this equation here. And there's also another equation for calculating the relative humidity. If the temperature is known, like it depends on the data that you have. If you have the data of the actual vapor pressure, you can calculate it with this equation using the temperature for calculating the saturated vapor pressure. And if you have the dew temperature, dew point temperature, you can calculate it with this equation. For direct measurement, if you want to know the humidity without the equation, a psychometer is used. It is a pair of wet ball thermometer and dry ball thermometer. I can show you in the next slide. This one is the psychometer. So it has here we have BK of bola kering, dry ball, and there is also BB, bola basah, wet ball. So the dry ball and wet ball thermometer, it has like a stick here, yeah, and this is the wet cloth. And here we have the humidity table for psychometer. You can see the percentage of the humidity based on the gap between the thermometer dry ball and the wet ball thermometer. Like here, there is also the thermometer, the wet ball thermometer can be like we can read the wet ball thermometer and the dry ball thermometer, and we can see the gap between these two thermometer, and then we can see based on the degree of centigrade, and then after that we can get the percentage of humidity. Yeah. For example, here we have data of air temperature and dew point temperature. The question is we have to calculate the saturated vapor pressure first, then we can see the relative humidity, and then we can calculate also the actual vapor pressure. So from this data, we have the air temperature and dew point temperature. Of course, we have to use the other one equation, like not the first equation but the second equation for calculating the relative humidity, right? And here we have to calculate the saturated vapor pressure first because of the question. Here we can calculate it based on our air temperature here, 20 degrees Celsius. And then after that, we can calculate it based on the unit millimeter mercury, millimeter of mercury. Like here, from Pascal, yeah, we can convert it. And then after we got the saturated vapor pressure, we can calculate the relative humidity using this equation here, based on our temperature. And actually, okay, yeah, we got the 77.88% of humidity, quite humid. And then after that, we can calculate the actual vapor pressure based on our humidity. Like if we calculate the humidity, we have to divide it, the actual vapor pressure with the saturated vapor pressure, right? So if we find the actual vapor pressure, we can use the saturated and the humidity one. And after that, we got this 13.67 millimeter mercury of actual vapor pressure. And yeah, after air pressure, we will talk about wind. Here, wind is the air moving from low temperature to high temperature. Wind speed measurement can be done with anemometer. Here is the equipment of anemometer. Or if you want to done it without tools, there's also scale named Beaufort scale. The Beaufort scale is an empirical measure related to wind speed for observation of conditions of land or at sea. So it's empirical measurement. And wind speed unit is usually kilometer per hour, miles per hour, meter per second, or knots. And here we can changing of the units between kilometer per hour to miles per hour, or knots to kilometer per hour. So wind speed measurements are carried out every day for a certain height. For example, here we have wind speed measurement for the height of 2 meters. If you get the speed data at a certain height, here for example 2 meters, you want to look for speed data or at other altitudes. For example, you want to look for the speed measurement at the height of 4 meters. You can use this empirical formulation based on the data that you have. Here we have the U is equal to wind speed at current altitude. For example, this at 2 meters. U0 wind speed at the original height. For example, the data that we know. And then we can use this equation. For example, we want to look for the wind speed at the altitude of 4 meters. Yeah, you can use this equation by using U0 as the wind speed at the height of 2 meters, and then the Z per Z0 is the altitude. So Z is the one that we look for example 4 meters, and Z0 is the one that we knew. For example, here is 2 meters. And then after that, we got the wind speed at the altitude that you want. Other empirical formula here, we have U2 equals to U1 times log 6.6 per log Z. Here we have U2 is the average wind speed at an altitude of 2 meters above the ground, here in miles per day. So here, if you use this equation, you have to use the unit of miles per day, right? Because it's empirical formula. So for empirical formula, it's really sensitive to the units, because if you have other units, sometimes you cannot use that empirical formula. and U1 is the wind speed at Z feet. Here, if you have 2 meters, you have to change it into feet, and then you can use it as Z here, as in feet. And then the next one is air pressure. Air pressure affects wind and evaporation. Usually it is measured by barometer with units of millimeter mercury or millimeter bar. And if you want to convert the units, you can do so by using these numbers. And there's also one equation which describe the relationship between air pressure and elevation. Here we have Laplace equation between air pressure at elevation C here, and air pressure at initial elevation here, P. You can calculate it with this equation. If you know the equation, the coefficient of air expansion and the average temperature to the elevation, you can calculate it using this Laplace equation. If you look for like air pressure at the elevation here, P, you can use the air pressure at the elevation Z that you know. Or if you know also the average temperature, you can put it here as T, and then C is the elevation. Solar radiation. For measuring solar radiation rate, you can use this equation LRM in N per N times 100%. Here we have the N, the small n is the exposure duration, and the big N is the exposure duration that can occur. For example, here if you have like exposure duration of like 9 hours in one day, and in one day you have 24 hours, so you can use the number for 9 per 24 times 100%, something like that. And there is also tools for this solar radiation measurement called sunlight measurement Jordan or Campbell-Stokes recorder or sunshine recorder. Here you can see in this picture, the recording is done based on the length of the burnt paper. So the burnt paper showing the time of the exposure duration. And regarding solar radiation, there is also a tool named solar radiation recorder. It is also can be used to record wind speed. So not only solar radiation, but also wind speed. The data of measurements is daily measurements, or can also be weekly measurements. It is obtained from the area defined by a curve with the time axis, and the unit usually is centimeters square or per day. And for calculating the radiation can be done with this equation, like the area times K times Ka. Ka is the tool coefficient, so it depends on the tool that we use. So thank you for your participation in today's class. And should you have any question, don't hesitate to ask. Maybe in the next lecture, or you can also ask through WhatsApp. And please fill out the attendance form in this link. Thank you very much. Have a nice day.